Hello everyone, this is GOC series and the first topic that we complete in this series is FMO. FMO is frontier molecular orbitals. These orbitals participate in a chemical reaction and the FMO, that is frontier molecular orbitals, are of two types. The first one is HOMO, that is highest occupied molecular orbital. HOMO is highest occupied molecular orbital. This simply donates electron. In a chemical reaction, these orbital will donate electron. And the second one is LUMO, that is lowest unoccupied molecular orbital. This will simply accept the donated electrons. In HOMO and LUMO, there is one thing common, that is molecular orbitals. These molecular orbitals are those orbitals which are formed by the combination of atomic orbitals like sigma, sigma star, pi, pi star, and the non-bonding molecular orbitals. The molecular orbitals are sigma, sigma star, pi, pi star, and the non-bonding molecular orbital. If we have to consider which one is HOMO and which one is LUMO, we must consider this example. Here sigma, pi, and non-bonding molecular orbital have one pair of electron each. Here the non-bonding molecular orbital is the highest occupied molecular orbital, so it will act as HOMO, and the pi star is the lowest unoccupied molecular orbital among sigma star and pi star, so it will act as LUMO. Let us discuss the examples of HOMO and LUMO concept. The first example, there is carbonyl compound and the proton. Here carbonyl has sigma, pi, and non-bonding electrons. The energy level is shown as this. The non-bonding electron is highly occupied, so act as HOMO. Whereas in H positive ion, the electronic configuration is 1 and 0. It means it has empty s orbital and act as LUMO. So in first example, carbonyl non-bonding electron will act as HOMO and proton empty s orbital will act as LUMO. In second example, there is CH3 positive ion and OH negative ion. Here OH negative ion has sigma and non-bonding electrons. The highest occupied energy level is non-bonding for OH negative, so non-bonding will be act as HOMO. Whereas in case of CH3 positive ion, the carbon p orbital is empty. Here this orbital will be completely empty in its excited state, and this orbital will be occupied by the electrons from the OH negative ion. So OH negative ion non-bonding electron will act as HOMO and carbon empty p orbital will act as LUMO. In third example, there is BF3 and NH3. In NH3, there are sigma and non-bonding electrons, and among these two, non-bonding electron has highest occupied, so it will act as HOMO. Whereas in BF3, there is empty p orbital. As we see its structure, the p orbital is totally empty and it will accept electron from HOMO, and therefore the p orbital of BF3 will act as LUMO. So in this example, NH3 non-bonding electron will act as a HOMO and BF3 empty p orbital will act as LUMO.